Hello guys, welcome to my channel Hima Education Made Easy. In this video, we'll be looking after bitwise operator. Okay. In our previous videos, we have seen that arithmetic operator, assignment operator, comparison, logical, identity, and membership operators. So we'll be moving on towards the final operator, that is bitwise operator. So bitwise operators are used to compare binary numbers. So here, if you are having a number that will be having a binary form, that binary forms we are going to compare over here. So in order to look for binary format of any number, then we need to go with print of bin, which represents binary of a. So here I have already assigned a value to a, so I'll be going with a. So here we'll be going to see what is the binary format of a. So here binary format of a is 1010. That is what we have taken over here. Okay, for our reference, I made a comment like 10 binary format is 1010, and then we'll be seeing about b, and what it returns we'll see now. Okay, it returns 100. So before we'll be taking a 0, so that we'll be having 10100 as binary format. So we'll go with a binary format of 0. What we'll be getting is all zeros. Okay, so all zeros, that is 0 of 0 binary format, that is what we'll be getting. So now we'll be going with AND operator and OR operator and XOR, that is XOR. Then we'll be going to NOT, then we'll be going to zero fill left shift and signed right shift. These are the things we'll be having in bitwise operator. So the first one is AND operator, then we'll be having OR operator, then we'll be having XOR, that is cap, then we'll be having a NOT. This symbol will be taken for NOT. Right shift will be taken with double greater than. Left shift will be taken to double less than. So here this is a left shift and this is a right shift. Okay, so we'll be going with the example now. So here I'll be going with print of, then I'll be going with A and B. So here whenever you use this symbol, it will automatically assumes that it's using a bitwise operator. Then if I go and run, I'll be getting an output of 0. So here upon comparing these two, it will give an output of 0, because here it returns if one returns 1 if both the bits are 1, else it will print 0. So in order to understand that, I'm going with print of bin of A, and again I'm going with print of bin of B, so that you will be able to see all these things. Then after this thing, I'll be going with print of bin of A and B. These are the things I'm going to print. So now if I see here, upon comparing, first digit here will be of 1 and next digit will be of 0. So upon comparing 1 0, it will print 0 as first thing. Okay, so here it will be of much clear over here. So here first digit of 10 is first binary digit is 1, and whereas in 4 it is 0. So finally we have got 0. When there are two ones, then only it will print 1. If not, it will give us 0. So in second case also 0 and 1. In third case also we'll be having 1 and 0. In fourth case we'll be having 0 and 0. So finally we got all zeros in binary format, so that is an output of a 0. So for that it printed 0. Next we'll be going with OR. So in order to use OR, we need to use this vertical symbol, which will be presented on backslash of the above button, enter button. So you need to press shift and then you need to click on the button which is above the enter. Okay, So then here I'm also going to change print or symbol I'm going to take now, and I'm going to run this demo. So here finally if I go with our condition, I got an output of 14. That's why that is happening. So here it will compare these A and B. Whenever you go with these two, it returns 1 if either of the bits is 1, else it prints 0. So even if there is 1 is present in both of them, then at least one should be there. So 1 is present in 10, so it has taken 1 as an output, and 1 is present in 4 in second bit, so it printed 1. In third bit 1 is there in 10, so it taken 1. So in fourth bit we are having 0 and 0, so it has printed 0. So finally this is what the binary format of this thing. So here you can see that is binary format of 14 is 1110. Okay, then we'll be going with XOR, that is XOR. In order to use XOR, we'll be using a symbol called cap. Okay, generally in mathematics we'll be considering it as a cap. Okay, so here this one, in order to use to power in mathematics normal conventional way, we'll be using this thing. Okay, so here it returns 1 if one of the bit is 1 and other is 0, else it returns false. Okay, 1 only should be present in one statement. Okay, if not it will print 0. So now we'll run it and we'll see the output will be of same. Why? Because here here if you take 1 0, it has printed 1. It's 0 and 1, it has printed 1. 1 0, it has printed 1, and then 1 0 and 0, it has printed 0. If there is 1 present in next thing, if like 1 is present in 10 and as well as in 4 in binary format, then it will return 0. Okay, this is what you guys need to remember over here. And then we'll be going with not. Okay, so it runs once complements of the number. So here it will take complement, that is negative of these negative inversion of these things. So here we'll be going with only A will be going with. So here it can be done only to a single thing. Okay, so here bit of A I'm going to take it as, and then binary of A already we know, and then here also we need to change it to not A. Okay, so this operator is called not. It inverts all the bits, simply it reverses. Okay, it will make them to get turned over. So here you guys can see. Okay, this is how it will be. The value of minus 11 will be 1 0 1 1. So here what happens is, so it will reverse everything and it will add 1. Okay, minus complement, it will take it in this particular manner. Then we'll be going with 0 fill shift left. So here these operators are used to shift the bits of number left or right, thereby multiplying or dividing the number by 2 respectively. They can be used when we have to multiply or divide a number by 2. Okay, so if we go with bitwise right shift shifts the bit of a number to the right and fills 0 on voids left, and then it will fills 1 in the case of negative numbers. As a result, similar effect of dividing the number with some power of 2 will be seen over here. So here if I go with A as 10 and if I go with print of, okay, so here I'm removing this thing. So here I'm going with print of. So here I want to see the statement 2. So here I am going with a right shift of 1 is equal to, as I need to get an output, and then I'm going to perform the operation, that is a is right shift of 1. So one digit is moving towards right, so that it will give an output of 5. So it will divide the thing by 2. So what happens if we right shift this thing to 2? We'll see that too, and then if you run, then you will be getting an output of 4. So in this particular manner we will be moving this thing. Okay, and then similarly we can use left shift also. So left shift, it will multiply by 2. Okay, that depends on the number. If you give only 1, then it will multiply. If you give 2, it will multiply by 4, like that it will do. Then if we run it, then we'll be having this thing. So what happens if we go left shift of 2? So here I need to change this one also. Okay, so then if I run it, I'll be getting an output of 40. So if you go towards right shift, then it will divide by 2. If we give an right shift of 1, it will divide it by 2. If you give right shift of 2, then it will divide with 4. If you give right shift of 3, then it will divide with 6. Similarly, towards left also you will be having the same thing. Okay, with this we will be winding up the Python bitwise operators. So finally we'll conclude that there are 7 operators which are inbuilt in Python. Those are arithmetic, assignment, comparison, logical, identity, membership, and bitwise operator. With this, I'll be winding up the video. If you like the video, please do like, share, and subscribe.